All right, ladies and gentlemen, so today we are going to do our last new thing for this unit here, Quadratics Part 1. We're going to talk about graphing quadratics by factoring to find the zeros. So, same skills as we were working on the last lesson. We're completing the square, and we're going to be talking about graphing our quadratic functions to show intercepts, maxima, or minima. And to do that, we have two vocab terms. Our first term is this idea of x-intercepts, or zeros or roots. All three of those terms mean the same thing. They are the way we describe the x values that make our function equal 0, where y equals 0. They're the places that we cross the x-axis, just like our y-intercepts are where we cross the y-axis. X-intercepts are where we cross the x-axis. The other way that we talk about those is zeros or roots. So if I use those terms, they all three mean the same thing. The other vocab term for today is the idea of a vertex. And so we talked about it a little bit in the last lesson. It's that point of change in a parabola, either the point at the top where we go from increasing to decreasing, or if we have a parabola facing upwards, it's that point at the bottom where we go from decreasing to increasing. But the part that we care about is today, it's going to tell us that x value of the vertex is halfway between our two roots. So the vertex is that point of change, and now we can determine the x value of the vertex using our roots. When you have these two definitions, we will get ready to practice. So our first practice problem, I'd like you to write out the function w of x equals x squared minus 2x minus 8. And I have a few different steps that I'm going to follow here. The first thing I need to do is I need to factor this function. When I look at it here, I know from previous lessons that I need to find two factors that multiply to make negative 8 and add up to make a negative 2. So when I think about my factor pairs here, the numbers negative 4 and positive 2 are going to work. I can multiply negative 4 and positive 2 and I get negative 8. If I add negative 4 and positive 2, I get a negative 2. So my factored form of my function is going to look like w of x equals x minus 4 times x plus 2. If you're still struggling with your factored form, we can take that and expand it back out, and we would find that it is the same. Those are equivalent expressions here, just one in standard form and one in factored form. So to do that, now I'm going to pull out the zeros. And so the way that I'm going to write the zeros is I want to write them as ordered pairs. I know that my zero product property tells me that I need to have one, or at least one of those multiplied terms needs to be equal to 0. So in the first one, if I plug in a value of x equals 4, I get an output of y equals 0. In the second half here, if I plug in a value of x equals negative 2, I get an output of 0. So my two roots for this function are 4 and negative 2. So what I'm going to do now is I'm going to plot those 2 points. So in your notes, you should sketch the coordinate grid. And I see 4, 0, so that's this point right here. And I see negative 2, 0. Ooh, it's kind of hard to see my points here. It's really hard to draw dots. So I have 4, 2, 4, 0, and negative 2, 0. Well, now I need to find my vertex. I know from my definition today that that vertex, the x value of the vertex, is located halfway between my two roots. So what that means is my line of symmetry is going to be halfway between negative 2 and positive 4. So what I can do is I know that that line of symmetry, I'm going to draw it in this bright green here, is going to be along the line x equals 1. Well, if I didn't know that, what I could do to find the vertex, the x value of my vertex is going to be halfway between my two roots. So to find the halfway point, I add them up and divide by 2. So 4 plus a negative 2 is 2. 2 over 2 is 1. So the x value of my vertex is 1. Well, now to find the y value of my vertex, what do I need to do? Well, to find the output, if I know the input, all I do is I go back to that original equation. I'm going to take this original function and I'm going to plug in an x value of 1. So the y value when x is 1 is going to be 1 squared minus 2 times 1 minus 8. So 1 squared is 1, 2 times 1 is 2, and minus 8. 1 minus 2 minus 8 gives me a negative 9. So my vertex is going to be located at an x value of 1 and a y value of negative 9. So if I plot that point here, I find it there on the graph. I have 3 points. I have enough technically to draw in my parabola, but I want to find 2 more points to be sure of the curve here. So to do that, I want to find the y-intercept. Well, I know that the y-intercept of any function is going to be the excuse me, it's going to be the y value when x is 0. So to do that, there's 2 different ways I can figure this out. One way is I can analyze that original function. In standard form, the last term, that c value, is my y-intercept. So in this case, it's -8. Ooh, my purple spot dot is in the wrong spot. Let's put that in the right spot. My vertex was at -9, 0. It's really hard to draw circles. There we go, sort of right there. My y-intercept is at 0, -8. Right there. The other way that I can do it is I know that I want to find the y value when x is 0. So I can plug 0 in for x. When x is 0, well, I get 0 squared minus 2 times 0 minus 8. Well, that goes away, and I'm left with that -8. So I have 4 points. The last thing I want to do is I want to reflect that value. I want to take this value here, and I want to reflect it across that line of symmetry. I know because it's 1 unit away, I'm going to go 1 unit on the other side of the line. So my reflection is going to be at the point 2, -8. That's using our skills from geometry last year, where we reflected points. So now I have my 5 points, and I can connect my dots with a nice pretty curve, and it looks something like this. Your line should be much prettier than mine. It's hard to draw lines on the screen here. But if I see this, I can factor it. I can find the zeros, those roots of my equation. I use my roots and my original equation, or my roots and my factored form, to find that vertex. Then I'm just going to do the last 2 steps, those y-intercepts and the reflection, to determine my 5th point. If I take a look at this here it is plotted on delta, or on Desmos, which gives a much prettier curve than my messy lines here. But I see those same spots. I see my 2 roots, I see my vertex, and then I see my y-intercept and the reflection. Those are the 5 points that I should be able to identify on a graph. Let's try it again. This time we're going to deal with the function m of x is equal to x squared minus 6x plus 8. So pause the video for a minute and see if you can come up with the answers to this one on your own. I'll walk through it again in just a second here. So pause now. When you're ready, you can unpause the video. When I factor this out, I should find that my factored form looks like m of x equals, oops, there we go, equals x minus 2 times x minus 4. -2 times -4 multiply to give me positive 8. -2 plus -4 add up to give me that -6. That means that my zeros of the function are going to be when x is 2, y is 0, and when x is 4, y is 0. If I plot my points, I have 4 and I have 2. My vertex, well, I can use the eyeball method here. I know that that vertex is going to be halfway between the 2 points. So my x value for my vertex is going to be 3. I can go through the process of 2 plus 4 divided by 2. Gets me to the same answer. My x value for the vertex is 3. So for my y value, now I need to plug in 3. And I can plug it into the original equation, or I can plug it into the factored form. This time let's plug it into the factored form. Minus 4. When I do that, I find out that I get -1 times positive 1. So my final answer, the y value, is -1. So I get 3, -1 as my vertex. 3, -1. Do it in green here because it's kind of hard to see the yellow and the yellow. My recording died in the middle of the last slide here, but we were talking about the vertex. So the vertex should have been at 3, -1, which I see right here. The last step would have been to find that y-intercept, and I know that my y-intercept is going to be positive 8 when I look at it in standard form. Last thing I need to do is reflect it across that line of symmetry. I know that it's 3 spaces away from the line, so I need to go 3 spaces on the other side, and I find that the 5th point here is at the point 6, 8. So the 5 points that you should have on your graph, the vertex was at 3, -1. My zeros were at 4, 0, and 2, 0, that looks like a 3, that's a 2, and the y-intercept of 0, 8. 5 points, there's the Desmos graph. Yours should look similar. Well, now on this next one, we're going to try it just a little bit different. If I see this equation here, I don't have an a value of 1 in front of x squared. Remember, when we're thinking about our quadratic functions, we're thinking about y equals ax squared plus bx plus c. Ooh, that's a 6. Plus c. So I need to think about how I can factor this using the skills that I have. What I need to do when I see this is I need to use the idea of greatest common factor factoring, because I want to make the coefficient in front of my x squared needs to be a 1, and it's currently a -2. But I know that I can take a -2 out of each piece. So when I do that, I can take a -2x out of each piece, and I'm left with x minus 2. If I expand this back out using that greatest common factor, I wind up with my original function of -2x squared plus 4x. Be careful with your positives and negatives here. So the next thing I need to do is I need to find the zeros. And the same process applies even though I have a single term instead of a binomial. Either this piece or this piece needs to be equal to 0. So my two possible options, well, when x is 0, y is 0. And when x is 2, y is 0. So my 2 points look like 0, 0, and 2, 0, right there. To find the vertex, I need to find that halfway point. That line of symmetry is going to go through x equals 1. So my x value for my vertex is 1. My y value for my vertex, well, I'm going to plug 1 into the original equation, and I get -2 times 1 squared plus 4 times 1. Well, -2 times 1 squared is still -2. 4 times 1 is 4. So my vertex is going to be when x is 1 and y is 2. Oops, there we go. Vy is 2. So my ordered pair looks like, let's switch to green. Yeah, we'll go to blue now. The ordered pair 1, 2. Well, if I see that here, I should notice that my parabola is going to open up this way. It's going to be an upside down parabola. I should have been able to recognize that from my key features here. That a value being negative tells me that I have that U-shaped down parabola, and that c value is 0. So that tells me that my y-intercept is 0. If I reflect my y-intercept, I wind up at the other 0. So for this parabola here, I only have 3 points, and that's okay. My y-intercept is 0, 0. If I reflect it across, I wind up at that 2, 0. So the same points as I have here. When I do that, and I connect my dots, I get a curve that looks something like this. Yours should match. I'm going to show you the Desmos version of it that's much prettier than mine. Here we go. This is what our parabola should look like. We should be able to recognize those key features. The a value being negative means our parabola faces downwards. C value being 0 means that we go through the origin. Here's just all 3 of those graphs that we did as examples on the same coordinate grid. I think it's interesting to see that we can figure out how we are shifting around and how we are transforming these quadratics. We know from Friday that when the absolute value of a is greater than 1, we have a steeper parabola. And I see that with my green one here, that it's steeper than the parent function of x squared, or -x squared in this case. I know that I can shift up and down. I can do that vertical shift by changing the c value, by changing where I cross the y-axis. The last piece we added in today is that horizontal shift, where we can shift left and right due to those b values. We'll figure out another way that we can manipulate that horizontal shift later in the next unit, I think. But for now, you have the main skills where we can graph and we can manipulate our parent functions. For this last practice problem, let's try going the other way. We're going to start with this factored form and see if we can pull out the key pieces to be able to graph this. When I look at this factored form here, I should be able to find those zeros. I know that my zeros are going to be my x value when y is 0, my roots of the equation. Well, to make that first factor into a 0, I have to plug in a value of x equals -3. To make the second factor 0, I have to plug in a value of x equals 1. So my two zeros are -3 and +1. To find the vertex, well, to find the x value of the vertex, I need to find the halfway point between my two roots. To do that, I take the first one plus the second one and divide by 2, which gives me a -2 over +2. So the x value of my vertex, or the line of symmetry, is going to be x equals 1. To find the y value for my vertex, I need to plug that into my function. And I get -1 plus 3 times -1 minus 1, which gives me 2 times -1. So the y value of my vertex is going to be -4. Positive times a negative gives me a negative. So the ordered pair looks like -1, -4. To find my y-intercept, there's two different ways I can do this. One way I can do it is I can take my standard form and I can expand it, or I can take my factored form and expand it back into standard form. So I get x times x minus x times 1 plus x times 3 plus 3 times -1, so that -3 there. So I get x squared plus 2x minus 3. Well, my y-intercept is that c value of -3. The other way to do that is I know that my y-intercept is the y value when x is 0. So I can plug 0 into my function to find the y value. So I get 0 plus 3 times 0 minus 1. Well, 0 plus 3 is 3. 0 minus 1 is -1. 3 times a -1 is going to be -3. So I know that my y-intercept is at the value 0, -3. Well, now I'm almost ready to graph. I have 1, 2, 3, 4 of my points ready to go. The fifth point is I want to reflect that y-intercept over my line of symmetry to find the fifth point. My line of symmetry is the line x equals -1. So when I reflect it across, I should get the value of -2, -3. If that's a skill you're struggling with still, that's okay. Graph it on paper. I think it's easier to see in a visual way. But if I were to plug this into Desmos, my graph would look like this, and I see those 5 points. I have my two roots at -3, 0, and 1, 0. I have my vertex was blue, at -1, -4. And then I have my y-intercept in red at 0, -3. And if I reflect it across, it winds up at this point here. And I can connect those 5 points and make a nice smooth curve. Last example that we're going to do right now is from the homework, where I have y equals -x squared minus 2x plus 3. Now this one's a little bit tricky because the first thing I need to do is I need to make my function into the form ax squared plus bx plus c when a is a +1. And right now I see that a is a -1. Remember that a -x squared is the same thing as saying -1 times x squared. So my first step before I move on is I need to factor that -1 out of each piece. So I get y equals -1 times, well, -1 times x squared. -1 times a +2x gives me that -2x. And then -1 times a -3 gives me that +3 at the end there. So now what I need to do is I can factor that inner piece. Now that I have an a value of +1, I can factor it out. That negative sign out in front is still important. It's still essential. So I'm going to write y equals -1 times, well, if I look at this here, I need factors that multiply to make a -3 and add up to be +2. So my two factors, I know one's going to be positive, one's going to be negative. To give me that negative, I know that the bigger one must be positive so that I end up with a positive. My factored form should look like -1 times x plus 3 times x minus 1. So now the zeros. Well, to make my function 0, I can't do anything to the -1. To make this piece 0 when x is -3, y is 0. To make this piece 0 when x is 1, y is 0. So I can plot my two zeros. -3, 0, and +1, 0. To find my vertex, my next step is to find the vertex. My x value for the vertex is going to be the halfway point between -3 and +1, which is -1. We can do it visually, or we can add them up and divide by 2. To find the y value of my vertex, I need to plug -1 back into my function to determine the output. I can plug it into the regular form or the standard form, or I can plug it into the factored form. If I plug it into the factored form, let's walk through the steps here. I get -1 times the 2 times the -1, which gives me a y value of +2. So my vertex is at -1, +2. -1, +2. Oh, quick little error there. -1 minus 1 is a -2, not a -1, which changed my final answer to, oops, still negative times a negative is a positive. 1 times 2 times 2 is +4, not a +2. There we go. That looks better. So I have my vertex is, fix it here too, -1, +4. Last thing I need to do is I need to find that y-intercept, and then I need to identify the reflection point. So the y-intercept is going to be that c value. I can pull it out of that one there, or I can plug 0 into the factored form. So my y-intercept is going to be, when x is 0, y is 3. That makes sense. Last thing I need to do is I need to reflect it across that line of symmetry. That line of symmetry is here through the vertex. It's 2 spaces away, so I know that this one's going to be 2 spaces away. My reflection point will be right here at -2, +3. So if I draw in my curve here, looks something like this. And there's the Desmos version. My points were in the right spot. My curve was not drawn super accurately, but the idea was there. I know that my curve is going to face downwards. That parabola is upside down because I see that -a value in front. I know that my y-intercept is +3 because I see that c value there. So there are some pieces that I should be able to pull out from the equation before I graph it. And then the other pieces, to find the other points for my curve, I can use my factored form and find the roots. So your job tonight and tomorrow is that worksheet that's on Teams. It's double-sided. You should do one side today and then one side tomorrow. Space it out. I really want to make sure that this is sinking in. This is your last day of new stuff. Later this week, we'll have a day of review, and then you will take the test. Whether you're in the building or at home, everybody's going to take the test on the same day. So that way we are ready to go when we have everybody, or we have both A cohort and B cohort in the building next week. Thanks for working hard, ladies and gentlemen.